Good morning, Madam Hitiana and all my fellow friends. Today we're gonna present about the title that we choose is Scalar and Vector. And my group members is me, Darren Devenci Duma, and Muhammad Exan, Ladum bin Albert, and Winley Majinsi. Okay, so we go to next slide, contents. In the contents, we have 5 contents, and 1 topic, and 2 application of vector or scalar in selected area, 3 mathematical solution with drawing, and 4 conclusion, and 5 Q&A season. So we're gonna to next slide. Introduction of scalar and vector. Definition of vector and scalar. Physical quantities can be classified under 2 main headings, vector and scalar. A vector quantity is any acceleration, force, momentum. A scalar quantity is any quantity that has magnitude only, while direction is not taken into account, e.g. speed, pressure, temperature, energy, and vectors. So we go to next slide. The difference between scalar quantity and vector quantity. And scalar quantity, we have 6 examples. 1. Scalar quantity has only magnitude but no direction. And 2. Every scalar quantity is one-dimensional. And 3. Any change in scalar quantity is the reflection of change in magnitude. And 4. Scalar quantity cannot be resolved as it is exactly same value regardless of direction. And 5. Any mathematical operation carried out among 2 or more scalar quantities will provide a scalar only. However, if a scalar is operated with a vector, then the result will be a vector. And the last one, few examples of scalar quantity: length, mass, energy, density, and etc. And we go to vector quantity. Vector quantity also have 6 examples. 1. Vector quantity has both magnitude and direction. 2. Vector quantity can be 1D, 2D, and 3D. And 3. Any change in vector quantity can reflect either change in direction or change in magnitude or change in both. And 4. Vector can be resolved in any direction using sine or cosine of the adjacent angle. And 5. Result of mathematical operation between 2 or more vectors may give either scalar or vector. Dot product of 2 vectors give only scalar, while cross product or summation or subtraction result in a vector. And the last one, example of vector quantity is the displacement, velocity, acceleration, force, and etc. And we go to next slide. Scalar, vector. Scalar. A scalar quantity has magnitude only. For example, speed, mass, volume, and time. And vector. A vector has both magnitude and direction, velocity, weight, and fraction.
Okay. Law of vector. Vector addition can be defined using any of the following law. 1. Triangle law. If 2 vectors are denoted by the side of triangle is the same order, the resultant vector is given by the third side of the triangle taken in the opposite order. 2. Parallelogram law. If 2 vectors are denoted by 2 adjacent sides of a parallelogram, The resultant vector is given by the diagonal that touch the point of intersection of those sides.
Next, a magnitude of a vector formula. There are different ways to calculate the magnitude of the vector. Based on the given data, use a different kind of formula to find the magnitude of a vector. The magnitude of the vector A is represented using the modulus operator. There are various formula that are used to count the magnitude of the vector. The following image show the important formula used to find the magnitude of the vector. So that is example magnitude of the vector formula. A equal square root x1 power 2 plus y1 power 2 plus z1 power 2. Vector V equal square root x power 2 plus y power 2. Vector V equal square root x2 plus x1 power 2 plus y2 division y1 power 2. The magnitude of the vector is calculated using the step discussed below. Step 1. Identify the x, y, and z component of the vector. Step 2. Find the square of all the x, y, and z component. Step 3. Add all the square found in step 2. And step 4. Find the square root of the sum obtained in step 3. Now we are going to next slide. Magnitude vector and unit vector. Magnitude vector. The magnitude vector is defined as the length of the line segment AB and right as AB. For further explains, we represent the magnitude vector using theorem Pythagoras. So this is the example about the magnitude vector using theorem Pythagoras. So we are going to next slide. Here have magnitude vector and unit vector. Unit vector are commonly used to indicate direction with a scalar coefficient providing the magnitude. Vector decomposition can then be written as a sum of unit vector and scalar coefficient. So here we have an example. The formula of unit vector is a fellow. Unit vector equal vector square root magnitude of the vector. So in solution, vector P equal 4 power 2 plus negative 3 power 2 plus 5 power 2 equal square root 50. Vector P equal vector F square root P. Vector P equal 4 square root 50 I division 3 equal 50J plus 5 equal 50K. Now we are going to next slide. Scalar dot product. The scalar product or dot product of two vector given equal A. Vector A equal x1 plus y1 and vector B equal x2 plus y2. So vector A kali vector B equal x1 y1 plus x2 y2. Next slide. here we have area of parallelogram and area of triangle. So here we have to example the area of parallelogram ABC. A equal vector AB kali vector BC. So in this image we can see the triangle ABCD. Area of triangle ABCD formula A equal 1/2 vector B kali vector BC.
Next slide, area of parallelogram and area of triangle. Example, find the area of triangle ABC. A 2, 3, 5 and B -2, 5, 7 and C 4, 0, 5. And this is the solution that we choose.
Conclusion. In conclusion, in engineering mathematics, a deep understanding of scalar and vector concept is crucial for analyzing, designing, and comprehending complex systems. Scalar are used to measure quantities such as temperature, pressure, and voltage, while vectors are used to represent force, velocity, and displacement in various engineering applications. By employing these concepts accurately, mathematical engineering can design more sophisticated and efficient systems and make more informed decisions in technical problem solving and design.